Hi everyone, welcome to the Earth Science Regents Review podcast series created by Hommocks Middle School Earth Science Department. Today we're going to focus our attention on the solar system. Well, in order to understand the solar system, we have to have an idea in terms of how old the solar system is. Our universe is between 13 to 15 billion years old. The Milky Way galaxy is about 10 billion, and our solar system is a mere 4.6 billion. So it's very important for you to understand the ages of each one of those three and also the sizes, the universe being the biggest, solar system being the smallest. You also have to have an idea in terms of where we're found within our Milky Way galaxy. The Sun and our 8 planets can be found towards the end of one of the spiral arms. Now there are two models that we're going to talk about of our solar system. So the model that we know of today is very different from what it was in the past. The first model we're going to talk about is a geocentric model. Geocentric model is named after the fact that Earth was put in the center of our solar system. Well, because ancient astronomers couldn't understand that we are moving not only through rotation but also through revolution, they only could observe. So they saw the moon, the stars, the sun, the planets all rising in the east and setting in the west without actually feeling the Earth move underneath their feet. This idea was first determined by an ancient astronomer called Ptolemy. And as the objects moved around the Earth, the planets would also move in these circular motions called epicycles. Now this model was extremely complex and very, very difficult to prove, although it was widely accepted. It wasn't until Copernicus came around with the heliocentric model, which basically removed the Earth from the center of the solar system and put the Sun. And obviously this is going to be the model that was used today. So we have the geocentric model, the Earth-centered, the heliocentric model, the Sun-centered. Now the Sun-centered model leads evidence to the Earth moving. The Earth not only moves through rotation, which gives us day and night, but it also provides revolution as well, which gives us our seasons. Now, anything in our solar system that's going to move around the Sun is going to be part of our solar system, which includes comets, which are icy objects formed at the very outskirts of the solar system, meteors, which are chunks of rock. Now, meteors up in space are called meteoroids. When they enter the atmosphere, they're meteors, and when they strike the surface, they're called meteorites. And when they strike the surface, sometimes they'll make an impact crater. We also have big chunks of rock that orbit the Sun, which are called asteroids, and that's going to be found in between Mars and Jupiter. And the most obvious piece of space material moving around the Sun are going to be our planets. Now there are two groups of planets. The first group are called terrestrial planets. They're the 4 inner planets, Mercury, Venus, Earth, and Mars. They tend to have thinner atmospheres, they tend to be smaller in nature, more dense, and tend to have a very rocky surface. So they include Mercury, Venus, Earth, and Mars. And outside the realm of Mars is going to be the asteroid belt. Now the next grouping of planets are going to be the Jovian planets. These are the 4 outer planets. They tend to be much thicker atmospheres, they tend to be much more massive in nature, mostly gas with a little teeny tiny rocky core, and they tend to be less dense. And they include Jupiter, Saturn with its magnificent ring system, Uranus, and Neptune. So those are the basic planets that we'll have in our solar system. Now you do have a chart in your reference table, page 15, that you really should be able to learn how to use. I do have another podcast on this chart, so please make sure you check that one out as well. So that's it for now. Thanks so much.